Okay. Let me share the screen. We have completed till question number 30. Now we are going to start with question number 31. Structural isomerism and stereoisomerism should be taken into account when answering this question. Okay. So we have to consider both structural and stereo, right? Okay. How many isomeric alkenes with the formula C5H8 present in the mixture produced when 1,4 dibromopentane is reacted with NaOH? Okay. These are the 5 carbon, and this is the position 1 and second. Sorry. First and fourth bromine. So let's see how many possibilities are there. One alkene can be formed, have this formula. The other alkene can be formed, have this formula. There is no other possibility from where the hydrogen can be released. So these are the two possible structures, but the one other important thing that if you see this one, this double bond which is in the middle can show you cis and trans as well. So in total, in this case, one isomer over here, second and third isomer over here. Okay, so in total we are getting 3 isomers, which makes A, B, and D wrong, and C is our correct answer. Is this clear to everyone? Okay, now question number 32. The presence of a halogen in an organic compound may be detected by warming the organic compound with aqueous silver nitrate. Okay, what would happen? Precipitates of silver halide would form, and their color will help us to identify which halogen is there. Which compound would be the quickest to produce precipitate? Okay, so if you recall, as we move down the group, the atomic radius of the halogen increases, due to which chlorine have a strongest bond. Carbon chlorine have the strongest bond. Carbon chlorine have a bond weaker than that. Carbon bromine have a even weaker bond, and carbon iodine have the weakest bond. So due to the greater atomic size of the iodine, so here we have iodine. This makes A, B, and D wrong. So carbon iodine bond is going to be broken down more readily, which makes C the correct answer. Is this clear? Yes. Now, question number 33. 17.6 gram of pentane 1 all is completely combusted. Which volume of gaseous product is formed when measured at STP? STP is standard temperature pressure. Okay. So, pentane 1 all is an alcohol, right? So, its formula would be C5H12O. One undergo combustion forms carbon dioxide and water. 5 moles of carbon dioxide would form and 6 moles of water would form. At STP, water is liquid and carbon dioxide formed as a gas. Now, the other thing important over here is this is STP, not RTP. And at STP, you must remember that one mole of gas occupies 22.4 decimeter cube. And how could you know that? I think it is mentioned over here. See, at STP, molar volume of a gas is 22.4. And at room TP or room temperature conditions, the molar volume is 24 decimeter cube. Okay. Now, if I go for its MR, so see there are 5 carbons, which makes it 20, 12 times 560, 12 hydrogen, 72, and 1 oxygen. So 72 plus 16 gives you 88 grams, right? So 88 grams giving me 5 times 24 decimeter cube of gas. So if I have 17.6 grams, then how much volume of gas is produced? So if you need to calculate X, it is 17.6 times 5 times 24 over 88. Can anybody calculate and tell me the answer, please? Oh, sorry. See, I did the same mistake. We just discussed that it is 22.4 dm cube, so we have to time it 22.4 instead of 24. Sorry. So what is the answer we are getting over here? 22.4. Okay. So it means B, C, and D goes wrong, and A is the correct answer. Okay. Now question number 34. Just give me a minute, please. Corotyl alcohol. Okay. Here we have a formula. It contains carbon-carbon double bond and OH both. It's a colorless liquid which is used as a solvent. Corotyl alcohol will react separately with bromine, acidified potassium dichromate, and acidified concentrated manganate, and PCl5 under suitable conditions, which Roy is correct. Okay. So if we use bromine with temperature conditions, but this is wrong. The main product would be CH3, CHBr, CHBr, CH2OH. The double bond is going to be broken down and the bromines are going to attach to the carbons which had a double bond earlier. So A is incorrect. Now part B. Acidified dichromate, heat under reflux is correct. But if you recall, heat under reflux instead of CHO, we will get carboxylic acid. So this is wrong. B goes wrong. Hot concentrated KMnO4, heat under reflex, this would turns into alcohol. Oh, sorry, carboxylic acid. That is correct. But here, this double bond is going to be broken down with acidified dichromate. So C goes wrong as well. So it means your D option is correct. Where we use PCl5 at room temperature, and only thing happens that the OH is substituted by chlorine. So this is correct. Is this clear to everyone? Yes. Okay. Now question number 35. The skeletal formula of two organic compounds are shown. Okay. Because in C, the double bond must also be broken down here, Mahveen. Because when we use hot concentrated KMnO4 and we use heat under reflex, in this case, that alkene, there are double bond in alkene from where the molecule splits into two. Okay, so that's why C is not the correct answer. Which reagent can be used to distinguish between these two? Okay, if I talk about alkaline iodine, we can use this because this one is not going to give a test with this one, but this one is going to give a positive test with this one. So this is correct. Number 2 is acidified dichromate. So this is not going to do a test with any one of these because it's a tertiary alcohol and it's a ketone. So remember, neither ketone nor tertiary alcohol oxidizes. So 2 goes wrong, and if 2 goes wrong, then A, C, and D, all three are incorrect, and B is the correct one. And if you see 3, 3 is also be used because 3 would not give a positive test with this one, but 3 would give a positive test with this one. Okay. Yes, is this clear to everyone? Okay. Now question number 36. A carbonyl compound X reacts with HCN in the presence of NaCN to make a compound with MR85. Compound X does not react with Fehling solution. If it does not react with Fehling solution, so it means it is not an aldehyde. Okay. So C and A goes wrong. If we talk about butanol, so butanol is CH3, C with a OH, CN, CH2, CH3. And if we talk about propanol, propanol would be CH3, C, OH, CN, and CH3. These are the products which are when butanol and propanol reacts. So these are the products that will be formed. Here they have given us the MR. So in this case, 1, 2, 3, 4, 5 carbons. So 12 times 5 gives me 60. 1 nitrogen, 1 oxygen, and 3, 4, 5, 6, 7. So 60, 14, and 16 gives you 30. 30 and 60, 90, and 97. So B is incorrect. So it means that B is your correct answer if you have want to calculate the MR. So there are 4 carbons, which makes it 48, 5 hydrogens, 1 oxygen. No, not 5 hydrogens. 7 hydrogens. Okay, here we have 8 hydrogens, if I'm not wrong. 6, 7. No, 9. So the MR would be 99. Again, it's wrong. So 48 plus 7 plus 16 plus 14. So 48 plus 7, 55, 55 and 30, 85. See, so that's why D is the correct answer. Yes, is this clear to everyone? Okay. Now question number 37. Which compound produces butane 2-ol and ethanoic acid on hydrolysis? So if we hydrolyze this one, we are going to get CH3, COOH, and the rest one is a CH, which is bonded to 2CH3, right? And here we get then OH. So we are getting propane 2-ol, not butane 2-ol. So A goes wrong. If we look at B, CH3, CO2H, we are getting ethanoic acid. We got ethanoic acid in the first case as well. Then the rest one is a carbon with a hydrogen, a CH3 on one side, a CH2 and CH3 on the other side, and here we got OH. So here we are getting butane 2-ol. So this is a correct one. If you look, the carboxylic acid side have a more carbons, which makes C wrong. And here again the carboxylic acid side have a more carbons, so which makes D wrong. So B is your correct answer in this case. Is this clear to everyone? Okay. Now question number 38. Two 1 gram samples of Y are reacted separately and completely with sodium and with sodium carbonate. The volumes of the gases produced are collected and measured. Okay. With sodium, we are getting the double the volume as compared to the gas which is forming when it reacts with sodium carbonate. Just give me a sec, please. Okay. So if you look at A, in A there are both are alcohols. So remember, alcohol does not react with sodium carbonate. So in this case of A, we are not getting any mole of any volume of sodium carbonate. But for example, nil, and we are getting volume of with sodium hydroxide, we will get the volume, but there is no reaction with sodium carbonate. So A is wrong. if you look at over here, we have a alcohol and carboxylic acid. So with sodium carbonate, alcohol reacts, sodium carbonate reacts, and with with carboxylic acid reacts. Both would react with Na, but with sodium carbonate, only carboxylic acid would react. So in this case, we have only alcohol and that is a ketone. So ketone does not react. This makes C wrong. Here we have a ketone and carboxylic acid. Carboxylic acid react with both, but ketone does not react. So this makes D wrong. So here we are getting the double the volume of gases with sodium because both alcohol and carboxylic acid would react with sodium, and we get the half of the gas when it react with sodium carbonate because only carboxylic acid reacts with sodium carbonate. So that's why our correct answer would be B. Yes, is this clear to everyone? Now question number 39. The diagram shows a section of an addition polymer formed from two different monomers. One of the monomer is propene. What is the other monomer? Okay. Okay. So here we go. So one monomer is propene. Okay. So if we try to figure out where is a propene, so propene can be this one. So then from here, the other monomer starts. And it goes till over here because you see here you are again getting it's repeating again you are getting propene and again the same monomer. Yes, is this understandable to everyone? So we know the propene, we have to identify the other monomer. So if you look at the other fragment that we have identified from the structure, it is like this where there is a double bond over here. So if you count the number of carbons, 1, 2, 3, 4, 5, 6. And if you see there is no branch, right? Which makes A and B goes wrong. Just give me a minute, please. Okay. If you see here, there is a branch as well, but here you are not observing any branch, which makes C goes wrong. So it means with a linear carbon chain, we have only D. So D is your correct answer. Is this clear to everyone? Yes. We excluded A, B, and C all because of the branch, and here there is a branch. Uh, it is because C. What would happen over here? For example, here you have a one propene, and here you have another propene. when this double bond is going to broken down and the double bond from here, what would happen? This carbon is going to bond over here. In the similar way, when this double bond is broken down, this carbon bonds with this one, and here this bonds with the other monomer, and this bonds with the other monomer. But if you look at these two carbons, now these two carbons, as the double bond is broken down, these two carbons have a one bond lesser. There is no hydrogen is being added. So that's why these two carbons forms a double bond, and that's why you are observing the double bond over here. That's why it have a double bond, two double bonds. Is this clear? Okay. Now question number 40. A scientist uses either infrared spectroscopy or mass spectroscopy to find the particular piece of information. In which row has the best choice been made? Identifies the functional group in an organic compound. Infrared. Is this a correct one or not? Yes, it can be a correct one because infrared will help us to identify the functional groups, right? Now, but we have to assure the rest are either wrong or not. Identifies the functional group in an organic compound. Mass spectroscopy. No, completely wrong statement. Values of success ionization energy of sodium. Infrared spectroscopy. No, because infrared just provides the energy to vibrate the bond. No electron can be removed from the atom. Now, D part. Values of successive ionization energies of sodium. Mass spectrometry. So, if you go for the best choice, D also goes wrong because infrared spectroscopy is used to identify the functional groups in an organic compound, and that's why A is correct. Okay, so here we have completed the paper, and I'm ending the session over here, and tomorrow we will going to start a new paper. And tomorrow probably we have a class at around the same time, 10 or 10:15. Okay, so take care everyone. Allah Hafiz.